Hey guys, welcome to part 2 of this video. In the previous video, which you can catch up there, we defined what a network is, and then we talked about the various components such as the MAC address, the IP address, cabling, and we talked about what a hub was. In this video, we're going to talk about switches, routers, access points, and firewalls. Let's continue. And this right here is a switch. Now, from the outside, again, it looks like a hub with more ports, but its function is much better. Same diagram, only now there's a switch in the middle. So let's take the same scenario as before. This computer wants to talk to this computer here. This computer learns this computer's MAC address, and it sends the traffic to there. So it'll send the traffic to this switch. Now, what a switch does, at a very basic level, is it stores the MAC address of every device and the switch port that it belongs to. So it knows every device on the switch and what MAC address belongs to each switch port. It keeps a little table, kind of like a switch port operator from back in the day. That's what the term switching came from. And so traffic comes from here. The switch looks at his MAC address table, and it knows that, hey, this computer, it's right here, and it goes at this switch port here. It sends the traffic directly there. Computer responds back to this computer here, does the same thing, sends return traffic. Switch looks up this computer's MAC address, it knows it goes out this switch port, and voila. Much easier. These computers don't have to hear about it. It shortens the collision domain to one device and one switch port. And not only that, but switch ports are also full duplex. And that means every device can both send and receive traffic at the same time. So to sum up, a switch will learn the MAC addresses and that assigned to each switch port. It will switch the traffic directly from one switch port to another based on the destination MAC address, just like an old switch port operator. And it has no collision domains, which means devices don't have to wait to see if the line is clear before transmitting traffic. And as a bonus, it's full duplex, which means the device can send or receive traffic at the same time. Send and receive traffic at the same time. All of your wired devices will plug into a switch. That is the first stop for every device that communicates on a wired network. Now let's talk router. You might be thinking to yourself, actually, I want you to look over, if you're sitting at home right now, which you probably are if you're in quarantine, and look over at your router. The purpose of a router as part of an enterprise network is not necessarily the thing that's on your shelf right now. So I want to differentiate between the two. The device that's at your house is is more like a combination between a switch and a router, and probably an access point, which we'll get to next. So a router in this case is pretty much used when you want to send traffic from one network to another network. Routers don't route traffic based on MAC addresses, although it's part of it. It uses IP addresses and routing logic, which we'll get into much later, to figure out where to send traffic. So in this diagram here, I have two networks. These two networks are connected by a switch, which we already know what it does. So it sends traffic between each other within the same network, and then we have network B with a switch that does the same thing. Now, if you're an experienced engineer and you're watching this, you know that switches can technically do routing, but this is a conceptual video. So as far as this video is concerned, this switch is a layer 2 thing, which means it switches traffic within the same network. If this computer wants to talk to this computer over here, it needs a device that knows how to send or route traffic between two or more networks. This computer wants to talk to this computer here, and needs to talk to this router here. This router will look up within this routing logic, we call it a routing table, and it will determine the correct network it needs to go to and where to send it to that network. So it will go here. Now it can be more networks. So we could have a network C, a network D, a network E, and a network F, all that stuff. And the idea will still be the same. The router will take the traffic, and it will choose which network to route the traffic to, based on the route table. Now, to touch on a few of the other networking devices, one of them is an access point. This right here is a picture of a typical Cisco access point. Let's go back to the diagram here. So a wireless access point is, so that's the thing for an access point. It takes wireless traffic, from your laptop, from your cell phone, whatever. It connects it to an existing wired network. That's all it is. It takes your wireless traffic and it sends it to the wire, and it connects it to the existing wireless network. The last component I want to touch on for this video is firewall. All a firewall does is it accepts or drops traffic based on a defined set of rules. This right here is a really old example of a Cisco firewall. It's called an ASA, an Adaptive Security Appliance. And if we go back to the diagram again, so you can see I've added the firewall component here. So basically, I mean, you probably know what a firewall does. It can do things like it can block this computer from accessing the internet. It also keeps traffic, the bad traffic, from traversing the firewall and connecting to your internal devices. It can control what traffic to allow through your firewall. It can control what traffic to block. And, you know, it goes both ways. So it can also block traffic going from the inside to the outside based on a set of rules that you define. Now, lots of firewalls come with, you know, rules enabled by default, but you can tweak them to your liking. Yeah, but that's it for this lesson. I know this was quite a long one, but we had to get through it. There was a lot to get through. The next videos that you're going to see after this, the next video will be the network model. We're going to go through the OSI and the TCP IP network models. After that, I'm going to do a video on TCP UDP ports. And then finally, we're going to start with some basic networking, how one device talks to another device. We're going to really deep dive into that. Thanks for watching this video. Please like and subscribe if you want to see more. Other than that, you guys have a great day.